This video presents Trinity use case dealing with methods for integrating and utilizing data necessary for robotized production into product model at early design phases. Robot trajectory information integrated into digital design data at early design phase can be utilized in production phase for agile programming of robot trajectories and also in creation of AVR experience of products for training and marketing purposes. Next, we will present how this Trinity solution contributes to agile manufacturing. What are the actual benefits of this solution in agile manufacturing? Possible application scenarios and scale of investment required in order to utilize this solution. And lastly, we will provide short conclusions of this use case. Agile methods for robot programming are needed for more flexible and profitable production. AVR solutions and digital twins can be utilized in example for personal safety and other training purposes. Other training purposes might be marketing and maintenance personnel training. Benefits of this use case approach are Agile programming approach for robotized production and AVR solutions for training and marketing purposes. We will now present these mentioned benefits in more detail. Let's have a look at Agile programming of robots. Including production data into design data at early phase provides an agile way of automating manufacturing process. Data included can also be utilized in aftermarketing and personal training purposes. Include once methodology saves time by avoiding double work. By integrating digital context data into production of manufacturing companies provides an agile way for automating manufacturing processes and speeds up the design production time for new workpiece manufacturing. Necessary data for robotized workpiece production can be integrated into the workpiece design at design phase, and this data can be utilized by production engineers for robot offline programming at production phase. Let's have a look at AVR solutions. Digital twins can be created for monitoring and remote controlling purposes. AVR experiences for training and aftermarketing purposes can also be created. Digital context data can also be utilized when creating a digital twin of the work cell, which can be used in AR/VR environments for monitoring, operational support, training, safety and maintenance purposes. These two digital design concepts together provide significant advantages in operational and safety training, risk assessment processes and production efficiency. Let's have a look at possible application scenarios for this use case. Methods described in this use case provide a flexible and agile way to design products for robotized production. Goal is to improve profit, productivity and lead time. This goal can be achieved in following ways. Trajectory information is included in digital design content and decreases from design to product time. New employee training carried out in VR environment does not interrupt production. A VR experience can be utilized for product marketing purposes. Solutions provided here scale to various company sizes. Let's have a look at scale of investments. Hardware investments range from €1,000 to tens of thousands of euros, depending on devices invested. RoboDK software cost is about €3,000 per license. This Trinity use case approach provides methods for efficient robotized production design and production. This approach also enables flexible manufacturing of small production batches by providing tools for including trajectory information into digital design data. Thank you for your interest in this Trinity use case video. If you would like to know more, please have a look at our more detailed training material.